Power to the truth. This is Margo. This is Thursday, February 14th, 2019. And it's 4:23 p.m. Pacific Time, United States of America. So we have 2 new days worth of data from CAMS today. Yesterday we saw Sunday the 10th, and that's still up, but we've already seen that, and then they've added Monday the 11th and Tuesday the 12th. So I'm going to show these as separate movies with Monday as a base time and then Tuesday as a base time. The area I have pulled up is the Arctic, and the level is surface level. We've got an absolutely packed show today. We've got lots of earthquake news. I have some articles to share. I'm going to show you some stuff on NASA Worldview, and we'll actually see the flooded area in Australia and the smoke, this large wave of smoke moving across the Tasman Sea to New Zealand. So, you know, I try to keep these short, but it's just more and more every day. And then we've got comments that we have to go over, because we're in a world classroom and we're learning together here. And so it's I tell you, it's a full-time job. So here it is. I'm going to pause it at the beginning again. I forgot to do that. I was talking. But it goes into the Monday is the base date with the actual data, and then that's the forecast period there. So this is where we ended with Sunday, with this big release coming up out of the Kara Sea and even to the west of these islands up here, and then a large release building in Siberia here, and it was starting to spread out across the coastline of Siberia, and this release coming up from Norway, and a new release building coming up from Europe. So that's where we left it on Sunday. So let's see what happened on Monday. I'm going to pause it here. So on Monday we see that this Kara Sea filled up even more with the red, and then it moved around this island. This is October Revolution Island, and then moved across, and then it's actually coming up from the coastline. It looks like the land right around the edge of the Arctic Ocean there, in the red zone. And then the release is continuing to come up out of Siberia. And so when we look at this ledger, this bright red is about 2100 parts per billion, and as it goes darker it goes higher in the scheme of things. And this dark brown, this color, is anywhere between 2140 to 10,000 parts per billion. So that's what they had on Monday. And so now let's look at, now I have Tuesday chosen as the base time. I've got the Arctic and surface level, and I already have this movie loaded up. And so we can see it's spreading out over the Laptev Sea and the Chukchi Sea, and it's into this orangey color. And now in this forecast period it's coming all the way over to Greenland again. We've seen it do that, and then to the North Pole. and huge release here in the Kara Sea, big release here in Siberia, and those releases kind of spread out, and but then look at this coming across into Canada. There's something going on down here, releasing really big down here. It looks like from the UK. So we'll get a different view in a minute to see. So now it's in the forecast period. I'm going to pause it at the end of Tuesday so we can see the actual data. Okay, so here it is at the end of Tuesday, beginning of Wednesday, where it's now coming up, and this is all through the sea ice, and this is still in the dark up here. Coming up in the Laptev Sea, and then swirling around, coming up out of the Chukchi, East Siberia. This is where the East Siberia ice shelf is located, or Arctic shelf, and then big release here in the Kara Sea and so forth. So that's where we left off with the data. And now this is the forecast period, and they're forecasting it appears to be pretty accurate on the methane using their data model. The when you get into the actual, when the data comes in, it's pretty similar to the forecast period. So now let's change. I'm going to close out. I don't want to keep a lot of browser windows open because it uses up all my memory. So let's see where this is coming from. Whether we can see this large release from the Kara Sea, and then moving across Russia, and then coming up over here on the east side, and up here too. Oh, here's the, look at this building here over Europe, or coming out of Europe. Man, that is totally in the black area, or dark brown. There it is into Friday. Now moving into Saturday. And then we've got China's covered up, India's covered up, and it's kind of hard to see everything. See, here's India, and see it's moving down further. It's not just in northern India. It's in the Indian Ocean. We've seen this before. And as the weather begins to warm up a little bit, we're going to start seeing these large releases of methane again from the surface level. And Canada still has a lot. So I'm going to pause that. I'm going to make that as the background. Just going to leave that up. Now we're going to go over to NASA Worldview, and here it is today on the 14th with Australia. And we saw report from down under from one of my new viewers yesterday about this cloud of dust that's moving across from Australia all the way over to the southern island of New Zealand. Let's go back a day, and it's really pronounced here. And this is from the wildfires that are burning, and they've had lots, and they had the flooding. They had lots of rain, and now they've got wildfires after all the rain. Of course, they had a drought during their summer, and so it looks like, to me, this is smoke from wildfires coming all the way across. And here's this huge band that's moving straight across. So here it was yesterday, and then here's where it's moved up. And so now another thing I'm going to show you, we're going to go back to January 24th, and for people who have been following what's going on in Australia with the flooding, they had all these rains, so I wanted to go back to before the rains began, where we could get a really good view, where it's pretty much cloud free. So up here in this northern Queensland area is where the flooding is now happening. It's a wide area that got flooded out, and hundreds and thousands of cattle drowned. And I mean, I've seen the articles. I can't bear to share them here because it's just heartbreaking to see the pictures of all the dead cows and stuff all lined up, and it's just heartbreaking, and the kangaroos that died, and it just, you know, I can barely look at the headlines, much less read an article like that. But so we're going to go forward day by day and see how this storm came up. So here's the beginning on the 25th, and then here it's building some more. Here's the 26th. I'm not sure when the rain began. Here's the 27th of January, 28th, 29th. And sometimes you'll get these black areas that come across. This is just a feature of NASA Worldview, supposedly because the Earth is round and they're trying to flatten out their map. But whatever. Here's the 30th. Here's the 31st. It looks like this is when the storm is hitting on the 31st. And see, it's still raining. It's a huge area. It covered this whole northern peninsula and this whole, you know, like this whole northern quarter of Australia, it looks like. And here it moved on down. Here's February 3rd. It's still cloudy. Here's the 4th. Here's the 5th. And it's still, even after it stopped raining, it's still kind of cloudy there. So we can't really see good until here. Here's February 9th. And here's the first day where it's pretty much cloud free. And look at the water, the flooding here. This is incredible. This whole area, and it turned that area into a huge, like, muddy river, it looks like. And it looks like this area got flooded too. I'm not for sure, but this is, you know, this is making my stomach hurt to look at this. Here's the 10th. Here's the 11th. So this is a really good view of it, and there's very little clouds up here. There's the 12th, 13th, and now you can see this water moving into the ocean, flowing into the ocean. That's all brown from the mud. That's what's going into the ocean there. And here's today. And the black thing is over it. Let's see if we got anything yet for tomorrow. No, not yet. So I'm going to go back. So here it is from yesterday where we could see it really good. That's a huge area. That just blows my mind. So this is a forerunner of things to come, as we're seeing. And then of course here's all the smoke from the wildfires, so it just blows my mind to see all. Here's some more wildfires, and this is a forerunner of what we're going to be seeing worldwide with the way the climate is changing, the jet streams are changing, and everything is shifting, and nothing is normal at all. Look at this smoke coming across. Look at that. Then Tasmania had snow, so because they've had fires too, so it's just it's incredible. And they're going towards the end of their winter down, or their summer down there, as we're coming into spring up in the northern hemisphere. But we still have at least a month of winter weather, a month or two up here where I live. And we've had a lot of rain here in the Reno area. It's supposed to snow tonight, but a lot of snow up in the mountains still. So it's just, you know, it's off the charts, and nothing is normal, and you can't go on past behaviors and past anything. Look, it looks like here's some more flooding with the water, with the brown in the water there. So anyway, I thought we'd start off with that. Now I want to go to some news items. The first one I want to go to is from my new viewer, Zoe McFarlane from Down Under. Hi Margo. Hi Zoe. Thanks for covering us down under in your latest update. You're welcome. I've attached a link to a news item from Tasmania where they are experiencing snow even before the fires have subsided. Here in New Zealand, the Nelson Tasman District fire is still smoldering, though evacuated inhabitants have been allowed to return home in some valleys. The weather has gone berserk. Absolutely. And so now let's look at this article that Zoe sent us from Down Under, and it says, this is from ABC News. A remarkable end to the fire. Snow falls on parts of Tasmania as fires still smolder. And this is from Tuesday. Tasmania has received its first snow of the year, and it's falling on areas that were threatened by fierce bushfires just last week. And Tasmania is right down here. This little island right down here. That's Tasmania. or this whole island here. I'm kind of having a brain fart looking at all those lines there. This is Tasmania. Those are probably the different states. Oh, back to our article. And there's the snow. Anyway, people can read this. I'll leave it in the link below. It said there's still 34 active fires across Tasmania, including in areas that have now received snowfall. It began to snow at Mount Field on the Central Plateau and parts of the West Coast on Tuesday afternoon. You should see it this morning. It's nice and thick, and it's fallen on the new Mount Mawson buildings and has settled. The snow fell about 16 kilometers from the base of Mount Field in the visitor center. The road is still closed from the fire, so we can't actually access it. So here's their snowfall. Looks like they got a few inches. So that should help with putting out some of those wildfires, I would think. Here's and summer's not gone yet, and here's snow on someone's deck there. So there's that. So I will leave the link below for that article. So thank you, Zoe, for the report from down under and that article, and appreciate you being here. Now, the next article, and what I'm going to do is just pull them up from my show notes. I'm just going to copy and paste one article at a time in, so I don't have to have a bunch of browser windows open. This one is from Radio New Zealand, and this is about the dust cloud from Australia heading to New Zealand, and we just saw that. That's from yesterday. That's from NASA Worldview yesterday, it looks like. This was published February 14th. The big dust cloud that has been causing visibility and air quality problems in parts of Australia is heading to New Zealand. Met Service said it would be blown against the South Island and may affect parts of the central North Island on Friday. So we see that in spades here, where it's coming right across, and here's the South Island, and then it's probably going to be moving up to the North Island. A large dust storm swept parts of New South Wales and Canberra this week as a cold front pushed strong winds ahead of it across the southeast of the country. The storm brought wind damage and power cuts in the Canberra area, and thick dust was moving into southern Queensland. There's the flood, that flooded area. This is absolutely just from NASA Worldview, just like I showed you. The west coast of the South Island is forecasted to be affected by some of this dust from Thursday morning until Thursday night, and western parts of the North Island on Thursday night and into Friday morning. It's most likely to be seen as an extra redness in the sky during sunrise and sunset, and there may be an extra bit of haziness in the sky. You're probably going to have some particulates in that too, so you might want to be careful about breathing the air there, is my thoughts. So people can read this article if they want to know what's going on down there. Now let's pull up the next article. Okay, this is out of Radio New Zealand, and this is from February 14th. Gisborne, Maine's water leak prompts urgent water conservation plea. Now, this is about a water leak that they didn't discover, and now they've got a shortage on water. Gisborne District Council said has just 24 hours worth of water left in its reservoir storage after a major leak was discovered in the water mains. It's made an urgent plea for residents to conserve water, and industrial users must immediately put their water shortage contingency plans into place. The leak was found in the 40-kilometer pipeline that runs between the dam and a reservoir. A broken seal has been identified as the source of the leak, which needed to be welded. Food processors, who are the largest users of water at this time of year, would be most affected. The council said contractors were excavating at the site of the leak at Margo and repairing it could take until 2 a.m. Total ban on all outdoor water is in place, which means no car washing, watering lawns, or filling swimming pools. Meanwhile, a backup water plant is being prepared to take water from the Waipau River to supplement water supplies. And so they're saying it's river water and it's going to taste different, but it's safe to drink and this and that. And anyway, and Gisborne residents will have to conserve water for 3 days. So in case you don't know where Gisborne is, it's up here. It's right up here on this northeast side of the northern New Zealand, right there. So there's that news story. And one more from Down Under. And this is from ABC News again, and it says, bushfire closes in on New South Wales town of Tinga, second emergency at Tabulum. So let's see where this is first of all. So let's pull up Google Earth so that we have an idea of what we're looking at. So Tinga it's New South Wales, Australia. It's right down here. Okay. There's Tinga, and they've got a Tinga plateau. So we can see it's over on this eastern side, kind of in the middle, coming down. And so they're having bushfires. And what was the next one? Tabulum. Let's find Tabulum. And it's not very far away. It's just a little bit further to the east. So that's that same area, and that's where we're seeing the smoke come out of. So when we're looking at NASA Worldview, that's this area where this smoke is coming out of, right out of there. All right, so this is all related, and this was updated on Tuesday. The New South Wales Rural Fire Service says an out-of-control blaze is posing an immediate threat of lives and homes at Tinga in the northern tablelands. An emergency warning has just been issued for a bushfire near Tabulum, also in northern NSW, which has already destroyed homes. The bushfire at Tinga has burnt 6,288 hectares so far and is spreading quickly in multiple directions under strong winds. And then it tells all the roads that are involved. And here's a picture. The township of Tinga is under direct threat by the mammoth moving fire. Look at that. That looks really scary. Conditions are deplorable. The fire is raging. Crews have even had to be pulled out from the front of the fire because it's so fierce. It's the worst the region has seen for decades. That just looks like something burning from hell to me. It looks like a quaint little town. It looks like a fun place to visit. Five homes razed at Tabulum. Look at this. 5 homes were destroyed in yesterday's bushfire in Tabulum. So we need to say prayers for all of these people down under. And this is typical of what we're going to be finding. This is what's going to be happening around the world. So there's that. So I'm going to leave that up there in case we want to look at that. Now let's hop over to comments. And we're going to go down here. Oh, I want to start with Richard Neville left me a response. He was the one that had the old link to the sea ice on the Navy military website. And he says, "Thank you very much, Margo, for providing me with the right links. Drama over. I must be clicking on the wrong link in my favorites list." And thanks for your helpful reply in your 213 video. You're fast becoming my one-stop shop for climate analysis and links to analysis tools that are helping you. Power to the truth. And so you're quite welcome, Richard. I'm happy to be of help. Power to the truth. So I appreciate that response, Richard, and I'm glad that my videos are helping. And what I found was when I started doing this research was that most people who publish stuff or, put up postings about what they find or stuff like that, they don't leave the links to where they found the data. And it took me forever to get all of these links compiled, and it was just here and there, and one person would refer me to this link and someone would refer me to another link, and then it took me a long time to figure out how to use everything and then put it all together. And so I decided that I was going to share the links. Whenever I find something that's of use, I'm going to share the link, because this is to be shared. We shouldn't be stingy with the information that's out there. And the more people doing their own research, the better, in my mind. So thanks for being here, Richard, and thanks for your reply. And then all the rest of them are under my video from yesterday. Earth says, secret confession, I often play your vids at 1.5 speed to get the update quicker, or 1.25, and you always still sound good. And Valhalla says, I might try that, thanks. And I know these videos go long. I can't help it. I would like to keep them to about 40 minutes, but see, I've already been at this for 34 minutes, and not even done with, just started on the comments and not even done the earthquake report. So, you know, if it's easier for you to listen, you know, and get through it faster, you know, more power to you. So, thanks for sharing that, Earth, or ERTHH, and thanks for being here. And then Valhalla 56 leaves a couple of comments. Very important. Thanks for putting the links in the show notes. All your claims are backed up by the data. You're welcome, Valhalla. He says, so even the largest fusion bomb over 50 megaton was only a fourth of a natural explosion by a volcano, LOL. So, yeah, Mother Nature rules. So this shows that Mother Nature rules. And so thanks for your comments, Valhalla. And then Darren Koppel, I'm going to come back to that one. I'm going to address this Darren Koppel's comment last because I have some more links to share. I've got some research to share regarding his question. Seymour Rocks 97, who is Robin Westerner, says, I've just put this together. Many reasons to prove Dr. Michael Mann wrong. And then it's one of his latest blog posts. And so people want to go there and see what Robin has come up with to refute Michael Mann and what he's saying. I thought it was very well done, and so the link is right there on his blog post. Thanks, Robin, for all of your hard work, and thanks for being here and for giving me tips on articles and research and stuff too. Jody Connolly says, love your work, keep it up. We're in this together. We're all just on a journey through the spirit of life. Thanks for your kind and informed message. You're welcome, Jody, and thank you for your comment. And then we already saw Zoe's comment. And then this one is from a different video that's not climate change related. So, and then John Creed says, under my Arctic sea ice and melting permafrost video, LOL, if you want to see methane, just go on the CAMS website and look at Asia. You will see a mass dark red blotch of it being pumped out of China. I know, I show this all the time. Here, and here out of India, and here out of Europe, and it's awful. It's awful. So, anyway. John Creed, thank you for your comment. And thanks for being here, and you're right on. You're absolutely right. Now, this last comment that I'm going to go over is from Darren Koppel. He says, hi, Margo. Was wondering how much parts per billion of methane would be the livable limit. Now, frankly, I think that's a very good question. And I don't think anybody really knows, Darren. I mean, just a simple answer, but I've got some research I'm going to share. But frankly, I don't think anybody knows, and it depends on a lot of factors. Seymour Rocks 97 says, how long is a piece of string? It is more a case of how much heating the gas produces, and can we survive the effects on our ability to grow grains? And I agree with Robin, and you know, we don't know, and different parts of the world are going to have different levels of methane, as we've seen on CAMS, and so, and it's a whole thing. And then Jody Connolly says, look it up, it's easy. And no, it's not easy, Jody, because I did look it up, and it's not easy. And here's a clue, MSDS, now go figure it out. MSDS is Material Safety's description detail sheet or something like that. And those are used in in industry and in a factory. But so I don't think that really applies to what we're talking about here. So I think we need to take things in context and realize that we're looking at the big picture. We're not looking at, if you're a factory worker, you know, how much methane can you be exposed to before you croak. We're not really looking at that, and that's what an MSDS would show. So let's go over here, and the first thing I want to go over is when we're talking about methane, the problem is the heating that it causes as a result of it breaking down in the atmosphere. And it's a very light gas. We've talked about this before, but it bears repeating. It's a very light gas, and it's part of natural gas, and it comes from lots of different places. And when it's in the frozen state, of course, it doesn't bother us because it's under the water or in the ground. But then when it starts melting and being released, like from melting permafrost and different things, then it goes up pretty quickly in the atmosphere, and it gathers in the upper regions of, or mid regions, and depending on what altitude you're at, it might gather at the North Pole more than at the South Pole or the middle. Well, let's just look. We can just look and see right now. We can look at like if we look at total column, we can see the disbursement is so much different. And the largest is over here in China, but there's total column methane. But when you're going up in the atmosphere, it's different of where it gathers. So here it is at 850 HPA as we're going up in the atmosphere, and so it's mainly gathering in this northern hemisphere up higher. When you go up 500 HPA, it starts spreading out more. See, so it's gathered more at 500 HPA than 850 HPA. And then when you go to 300 HPA, which is even higher, and I don't have the numbers just right off the bat as to how high that is, so it's dissipated quite a bit here. But then when you go up to 50 HPA, watch this. It's really gathered around the mid-latitude, around the equator. So depending on where you are in the atmosphere, it gathers more, different areas of the world. And so when you have that, it affects the ozone, it affects the UV, it affects everything. So the next thing you want to think about is how much it actually contributes to the heating, because what I found was, in the few articles that I looked at, is that immediate exposure to ozone, it doesn't really affect us. If we have fresh air, we'll live. I mean, it's not going to kill us, but it's mainly the heat component. And we discussed this back on when was this? January the 14th, in my video Carbon Dioxide, Methane, and Earthquake Report on January the 14th, we talked about CO2 equivalent, and that's where You take the different levels of the greenhouse gases and convert them to what would be a CO2 equivalent in the atmosphere, and it comes up, if you do just ozone, just methane, it comes up to an equivalent of about 600 parts per million right now, or a little bit less. But so people can go to that video, and the comment will be under there. In fact, I'll leave the link to that underneath, and so you'll be able to look at that, and here's a link to finding the equivalency. So I think that's a better way to think about it, rather than thinking, well, when we hit a certain parts per billion, we're all going to die. I don't think that's the case, Darren. And I don't think anybody really knows. Seriously, I just don't think they know. So, but in the meantime, I do have some links. I did do some research on this, and it was not easy to find. I don't care what anybody says. So here's the first one from stackexchange.com, and it says, could humans breathe if the average methane content of the atmosphere increased to 1%? And it says, below is a table of atmospheric composition. Could humans breathe if the average methane content of the atmosphere increased to 1%? And it says the current average composition of the atmosphere up to the altitude of 25 kilometers or kilometers. And here, methane is currently at 0.00017% of all the gases that are made up in the atmosphere. So it's a low percentage. So I think what they're saying is you've got room to spare for actual breathing, but it's the effect of it, like how much heating is it gonna do. And the answer, I thought this was a good answer. It says, not sure what you had in mind, but if the atmosphere was 1% methane, there would be a massive contribution to global warming. I don't know if anyone has run a model with that much methane, but it could very well be an unsurvivable level for humans' time on the planet, regardless of direct biological effects. I thought that was a good answer. So I will leave all these links below, and people can look it up, or if you want to do more research on your own and see what you can find, you can share it with us. I mean, this is the global classroom. And then from Talkstown, I found just what is methane. It's colorless, extremely flammable, and it can explode when mixed with air. It's the primary component of natural gas. Natural sources of methane include termites, bodies of water, wildfires, and digestive processes of animals. Methane is released from coal deposits during underground and surface mining, and from decomposition of waste. And we found a whole lot of other areas too. So, breathing, most commonly, how can it be exposed to methane? From breathing vehicle exhaust and emissions from farms, landfills, and use of fossil fuels. And when it comes into contact, or if you touch liquefied methane, it'll hurt your skin. It'll frostbite the skin and burn the skin and eyes. It can cause suffocation, loss of consciousness, headache and dizziness, nausea and vomiting, weakness, loss of coordination, and increased breathing rate. And it says who's at risk. And it says everyone is exposed to low levels of methane in outdoor air. Some home appliances may emit methane. I'm thinking like gas stoves. And farmers can get it emitted from animal digestion and waste. So, you know, they're really talking about to get a high level exposure, you have to be in an enclosed area. When you start having these symptoms of the high levels of methane, it's really because you're in an enclosed area and it's a really high concentration of methane, and most of us are not going to have that unless you're working in a coal mine and you're the canary that's sent down there to see if there's any air. And if you don't come back, it means there's no air. Here's another link I found from Alberta, Canada, Agriculture and Forestry on methane safety, health effects. Here's exposure at 1,000 parts per million. Okay, we're okay for up to 8 hours at 1,000 parts per million, and 50,000 to 150,000 parts per million is potentially explosive. 500,000 parts per million can cause asphyxiation. So it says to filter exhaust air from animal houses. So if you're working with cattle and stuff, you can definitely be exposed to it. I say wear a gas mask too, of some kind. You know, a respirator. Make sure all your pits and manure storage areas are adequately and appropriately ventilated. Smoking should not be allowed around manure pits. Frequently test the levels of methane in the barn using an explosion meter. Do not lower fans into the manure pit because this practice could cause methane explosion. Prohibit all open sparks or flames in areas near pits or storage facilities. Electric motors, fixtures, and wiring near manure storage structures should be kept in good condition to prevent a spark from igniting the methane. Entry into a confined space should not be performed without a proper breathing apparatus. That's what I thought. Post warning signs to keep people away from dangerous confined spaces. Have someone outside the manure pit to call for help if needed. Do not try to rescue a person who's been overcome by the gas. Call for help immediately. So this is serious. They take this seriously. So they're mainly talking about on the farm, if you're working in a feedlot or something like that. Okay, I've got one more link to share on my research that I found on methane breathable levels. And this is from Canada, from Canadian Centre for Occupational Health and Safety. And it's a fact sheet. And it's just what it is. It can explode, can asphyxiate. High concentration can displace oxygen in air and cause suffocation, and it may cause frostbite, depending on the kind you come into contact with. It can accumulate in hazardous amounts in low-lying areas, especially inside confined spaces. Distant ignition and flashback are possible. Low concentrations are not harmful. This is for inhalation. A high concentration can displace oxygen in the air. If less oxygen is available to breathe, symptoms such as rapid breathing, rapid heart rate, clumsiness, emotional upsets, and fatigue can result. As less oxygen becomes available, nausea and vomiting, collapse, convulsions, coma, and death can occur. Symptoms occur more quickly with physical effort. Lack of oxygen can cause permanent damage to organs, including the brain and heart. Effects of long-term or chronic exposure, it says it's not harmful and it's not a carcinogen. So that's if the level is not too high. You know, it's not harmful for long-term exposure. So then they tell what to do for first aid and things like that. So I found this interesting to do this exercise, and so instead of just blowing it off and saying, oh, well, look it up yourself, you know, I mean, there are a lot of factors, and I thought it was a good question. So thank you for your question, Darren Koppel. We just learned a little bit more about methane. And so I think we've got a ways to go on us being able to actually breathe, but as far as livable, it depends on how fast it heats up the atmosphere. And the consequences of that heated up atmosphere are, you know, the jet stream going wonky and higher levels of water in the atmosphere, which causes more severe storms, more severe tornadoes, hurricanes, cyclones, you know, stuff like that. And also these atmospheric rivers where it just keeps dumping water forever and ever and ever. And large snowstorms. And so that's what we're up against. And as a result of that, then it'll be hard for us to produce and store grains. And this is exactly what Robin was talking about, and that's the bottom line that Guy McPherson talks about. So that's kind of a long-winded explanation for that. But I wanted to cover that for sure. And so that we didn't leave that undone. So now, let's get into our earthquake report. I've got USGS pulled up here, and for 24 hours for all magnitudes, and I've got 193 showing on the map here worldwide. And then if we go to the 2.5 magnitude and higher, we have 32 worldwide for the last 24 hours. So I'm going to start with, let's see what time it is. Let's see what's about to come off the map. I think I have time. So I'm going to start with these two over here in the Atlantic Ocean. These two came in within an hour of each other. These are the biggest ones. The first one came in, it was a 6.2. Originally it was a 6.1, but they upgraded it to a 6.2. This came in at 11:57 this morning. And when they don't know how deep it is, they default it to 10 kilometers. So when you think you see a whole bunch of earthquakes, oh, that's all 10 kilometers deep. Now that's the USGS's default for just to put something in the blank there. So, or either they didn't know or they didn't want to report on the depth. So we don't know how deep it was. And so this is right on the red line. And notice that there's no wave there for a tsunami. And I'm going to go over that in a minute. So that one came in at 11:57 this morning Pacific time, because I'm on Pacific time zone. And then at 12:43, less than an hour later, a second one came in that was 5.0 magnitude, right at the same place. So this is an active region. This is an area between two tectonic plates, and I found out why there was no wave for the tsunami warning. And here's an article that was posted from Hal Turner radio show, and it says that the tsunami buoy was offline. This was published today, and it says strong 6.1 magnitude earthquake strikes Atlantic Ocean, tsunami buoy offline. And it says a strong magnitude 6.1 earthquake has struck in the Atlantic Ocean well off the U.S. coast at a shallow depth of only 10.1 kilometers. So, I don't think he's aware that they default to 10. Anyway, but a tsunami buoy located west of it is offline and unable to warn the U.S. if a tsunami has been created. The buoy has been broken for almost 3 years. According to the National Data Buoy Center, a tsunami warning buoy is located near the location, right there, of this earthquake, because they knew the Atlantic Ridge posed a danger to the U.S. coast, but the buoy is out of service. Right there. And here's the information from the National Data Buoy Center, and here's where it's located, and it says as of 1300 Zulu time on April the 22nd, 2016, the buoy located at station 44401 has ceased transmitting. Data will be restored during our next service visit to this location, but it hasn't been updated since then. This means this warning buoy has been out of service for almost 3 full years. The next closest warning buoy is about 200 miles off the U.S. coast at about the same latitude as the offline buoy. Given that tsunamis travel at about 500 miles per hour, it would provide the people of New York City only about 20 minutes warning to get to higher ground. How do you evacuate 20 million people in 20 minutes? So there's that article. And here's the other buoy. Let's look at that. It's just an enlarged picture. So yeah, that would have been the closest buoy, because that earthquake happened right about here. So there's that. So that's the largest earthquake that's come in the last 24 hours. And I'm assuming there was no tsunami since we hadn't heard anything. But it's not very comforting to know that. I know. So now let's go around. I'm going to start up here in the Russian Kurilsk Islands here. There have been 2 in the last 24 hours. There's been a 4.9 just to the east of this Kurilsk Island. This one came in at 9:18 p.m. Pacific time last night, 65 kilometers deep. And then there was another one. This one came in at 10:53 this morning, 64 kilometers deep. Next we have this one off the coast of Japan, a 4.5 near Toba. This one came in at 5:45 p.m. yesterday, 362 kilometers deep. So that one was quite deep, and that will cause movement of the tectonic plates when it's that deep. Then moving on down to General Luna, east of General Luna, Philippines, we have two. We've had a lot of activity down here recently. We've had a 4.7 that happened at 3:57 this morning, 32 kilometers deep, and then a 4.8 that came in at 1:24 this afternoon, 35 kilometers deep. Coming on down, here was one just barely off the coast of this island, near Tobelo, Indonesia. The island is Pulau Morotai. It was a 4.9, and this one came in last night at 7:42 p.m., 45 kilometers deep. We can see these are all right near these red lines. Then down here, right off the northeast coast of Papua New Guinea, was a 4.5 near Lae, Papua New Guinea. This one came in last night at 11:54 p.m. and that was 126 kilometers deep. That takes care of that ring. Now over here in Iran, however you say it, was a 4.2 near Bandar Abbas, Iran. This one came in at 12 o'clock this morning, and right on that red line. And now let's go to Hawaii. Let's go to Hawaii next, because I tend to kind of space it out when I get into all this other stuff, so I want to make sure that I get it covered. We have 9 earthquakes here today, and the main one, well, these are all important, but this one here was a 3.3. That's the highest we've seen here for a while. It was off the north coast, near Honoka'a, Hawaii. It came in last night at 6:42 p.m. It was 6 kilometers deep, and there are all these active volcanoes on the island. Then up here, so we'll go around. Here was a 1.7, and then here at Kilauea there were 3. Here was a 1.9, and this one was at a minus 0.1 kilometers depth, meaning it was up in the chamber. The magma is moving. Here's a 1.9 in it as well, and a 1.8, and it was at a minus 0.2 kilometers depth. So whenever you see a minus kilometers depth, that means that the epicenter of the earthquake is above ground level, and it's up in the mountain or the chamber, and so it's from movement. Usually it's movement of the magma causing the earthquake. So this is all in the Kilauea volcano area. And then here was a 2.0 and 2.2 down here, and then one down here near Pahala, a 2.3. So, you know, there is still movement. Things are still active, and here's one in the ocean that happened, a 2.0. That one came in at 7:57 this morning. So it hasn't stopped. Things are still moving there, and so people still need to take care and be prepared for if something happens down there. Now we have a lot of activity down in South America. Let's just start down here. 4.5 near Calama, Chile. This one came in at 1:54 this morning, 130 kilometers deep. 4.5 near Cocolo, Peru. This one happened last night at 8:02 p.m., 143 kilometers deep. Here's a 5.4. This is the largest one in South America today. This one came in at 6:33 this morning near Pampas, Peru. Let's see. I don't see where Pampas is. Anyway, if that was in a populated area, that would cause damage. Then, moving on up, here's one. In this little bay area in the Golfo de Guayaquil, or Guayaquil. 4.7, they're saying is near Tues, Peru. This one happened at 5:42 this morning. Then here's one in Ecuador, near the border, up in the mountains. It looks like it was a 4.8 near San Gabriel, Ecuador. This one happened at 10:24 last night. That would be big enough to feel. It was 6 kilometers from San Gabriel. It looks like it was in sort of a remote area, so it probably didn't cause any damage. And then one in Colombia. This one was a 4.5 near Betania, Colombia. This one happened at 1:09 this afternoon, 63 kilometers deep. Now let's move on over to Dominican Republic. We've got 9 here today. Looks like they're all in the ocean. And I'll just call them off. 2.9, 3.2, 2.9, 2.6, 3.2, 2.9, 3.1, 3.1, and 2.4. So a lot of 3s and 2s there. Now let's go up to Alaska. Here's one in the ocean and part of the Aleutian Island chain of 4.1 near Otka at 5:01 this morning, 76 kilometers deep. Then moving on up, we're showing 40 here of all magnitudes. So the number has gone down. Let's see how many are above 2.5 magnitude. Only one right here in the Anchorage area, 2.9, and that one came in last night at 7:35 p.m. So the rest of them are under that, under 2.5, and mostly in the ones and a few in the twos range. And so we're not seeing as much movement up here today. It goes in cycles depending on where there's other movement around the planet. And let's see how many are here in this cluster, and what's in the viewing area is 25. So it's quieted down in Alaska today. Now coming on down into the lower 48. I want to start over here in Missouri. Oh, I have a picture to show everyone before we do that. Hang on, I've got it ready. This is a picture of the North American craton, which is it's a plate that's been the most stable under this North American plate. And the way that these plates are laid out, it's like layers of a cake is how people explain it. And depending on when they were formed from different time periods, you know, then they're called different things. But this brown area is the North American craton, is what that's called. And so let's blow this up so we can read it. And it says continental crust that has remained relatively stable for the past 600 million years. So normally we don't see a lot of earthquakes then in the area in the brown zone. But we can see like the purple area, that's called the deformed craton. And so the purple area goes out from to include this Yellowstone area, this whole Yellowstone region coming down, and then parts of Colorado and half of New Mexico, and then this like here's El Paso, and the southern edge comes across through Texas, and then it comes up and around and up around, and then up here through Maine, and then up into Canada. And so that's why occasionally we will see earthquakes up here along this edge in this purple area. And then the green is, it says accretionary belt welded to the North American continental margin within the last 600 million years. And so this is an area that's just highly active, and so that includes the Dominican Republic, that whole area down there. It includes Mexico, Central America, Costa Rica, all of those. So I wanted to share this with everyone, and I'll have it up so that we can look at this from time to time, and we can compare where these earthquakes are happening, and then we'll see, oh, well, that's on that curvature where the North American craton is. And Dutch Sense uses this, and that's how I learned about it. And I will leave the link below to the website. I think it's on Wikipedia that they had, but you can just Google North American craton, and there are lots of articles on it if you want to find out more about it. So I wanted to show that before I got into this. There was, now it fell off the map. There was one up here in Lake Ontario. Did I show that yesterday? I'm having a brain fart. But let's look at 7 days, all magnitudes. Here it is. So we can see in the last 7 days there have been 3 earthquakes up here. Uh-oh, I didn't mean to do that. Up here in that purple area, see? Here's one in New Brunswick, a 2.0 near Miramichi, Canada, and this one came in on February 11th at 8:26 in the morning. Here's this one in Lake Ontario. This one came in, this is a 2.0. It says near Hamlin, New York. This one came in at 11:29 yesterday morning. And then this one was a 3.1, and I did report on this one, I remember, near Greater Sudbury, Canada, and this one came in on February 7th. So, you know, this is just another way for us to be able to see the patterns of these earthquakes as we look. Man, when you do 7 days, all magnitudes, that's pretty impressive, isn't it? We don't realize how many stack up when we just see one here, one there, and we see them occurring pretty much in the same locations, the same areas. And so as this happens, it weakens the plate even more. So I just wanted to share that with everyone. So we'll go back to 1 day, all magnitudes now. And now this one is in Missouri. This is I consider this part of the New Madrid seismic area, U.S. hazard. It's on the edge of this New Madrid seismic area, and it was a 2.6 that happened near Mountain View, Missouri. So that's pretty good size, and that one came in at last night at 8:46 in the evening, and it was a 6.7 kilometers in depth. Now that's not really part of the craton. Why do I keep doing that? I don't think we have some earthquakes over here that are probably part of that craton. So let's just move on. Then our next earthquake, I'm going to turn this off, happened in Oklahoma. There was a 2.6 near Pawnee that came in last night at 10:25 p.m., 5 kilometers deep. Then moving on up to Utah, we're still seeing quite a bit of movement in Utah. Let's start over here. We've got 2 here, 1.7 near Beaver, Utah, and this one came in at 10 o'clock this morning, and it's at a minus 0.1 kilometers depth. So that was up in the chamber. And then there was a 1.7 near Fillmore, Utah, that happened at 9:28 this morning. Then moving on over to Farron, remember we've been seeing swarming here. I thought it was going to slow down, but we've got 16 on the map here today. And a whole lot of them are at negative depths. So we've got a 1.5, 1.4. This was at a minus 0.5 kilometers depth. 1.2, 1.5, 1.0, 1.0. This was at a minus 0.9 kilometers depth. 1.5 at minus 0.3 kilometers depth. 1.8 at minus 0.7 kilometers depth. 1.7, 1.6 at a minus 0.7 kilometers depth. 1.8, 1.9, 1.6, 1.6, 2.0 is the largest one at a minus 0.5 kilometers depth, and a 1.6 at a minus 0.7 kilometers depth. So we're seeing how many here now in the last 7 days. I'm just curious. 76. 76 right here in the last 7 days. And some of them from the week before have fallen off now. So something's happening. I don't know what. Then we've got 3 up here near Carbon City, Utah, 1.7, 2.0, and this was came in last night at 8:03 p.m. This was a minus 2.5 kilometers depth, and then a 1.9 that came in at 10:15 last night at a minus 3.4 kilometers depth. So it's up in the chamber again. So they've got stuff happening in Utah, and that is on the craton. That craton comes down, the edge comes down like this, down through here. So now let's move up into into Yellowstone. What's this? Okay, well, we've got some activity here today. We're showing 12 on the map, and so let's just start with this one down here. We've got a 1.7 near Soda Springs, Idaho at 9:17 this morning. Then let's go over here. We've got a 2.6 near Chalice, Idaho that came in at 3:28 this afternoon, and a 2.2 near Chalice that came in at 4:10 this afternoon. Then up here was a 1.3 near Salmon, Idaho at 6:23 this morning. 1.3 near Salmon, Idaho that came in at 6:24 this morning. So those were only 1 minute apart. Then moving on over, we had a quarry blast that registered a 1.0 magnitude near Dillon, Montana. This came in at 10:34 this morning at a minus 2 kilometers depth. Then there was a 1.4 near Virginia City, Montana at 4:10 this afternoon, and a 1.2 near Virginia City at 4:14 this afternoon. So we're seeing them in pairs again. Like I said yesterday, just within either a few minutes or maybe an hour, we're seeing these in pairs. Here's a 1.9 near West Yellowstone, Montana at 1:03 this afternoon, and a 1.1 near West Yellowstone, Montana at 5:03 this morning. And moving on up, here's this one right on the road. 1.3 near Manhattan, Montana at 10:09 this morning. Then a 1.3 near Lincoln, Montana last night at 9:14 p.m. I think that's all up there. Now let's look up in the northwest. We've got one southeast of Seattle. It's a 1.2 near, they're saying, near Renton, Washington at 8:08 this morning. See if there are any blasts or anything. I don't think so. Coming on down into Oregon. Nothing being reported in Oregon. Okay, here's one near Mount Shasta. Here's Mount Shasta in California. It's not at the mountain, but it's in the same area. A 1.3 near McLeod, California. This one came in last night at 7:41 p.m. Then coming down into Northern California, we've got two right here. A 0.7 near Chester, and a 1.0 near Mineral, and this one was at minus 0.8 kilometers depth, and we see it's in this Lassen area where this Lassen mountain volcano is. So that's up in the chamber there. And then at the geysers, we've got 21 here today, so that's active. And they're in mid 1 and under, except for this 2.8. That appears to be the largest one. That one came in at 4:37 this afternoon. 1.8 kilometers depth. Let's look at 2.5 magnitude and higher. Yeah, that's the largest one there. Now, coming across to Nevada, we've got one north of Pyramid Lake, a 1.7 that came in last night at 8:04 p.m. Nothing in the Reno area, Lake Tahoe, Carson City is quiet. Let's see. Here's one on the border near Mammoth Lakes at 1.4. I'm trying to finish up Nevada first before we go to California. And then we've got some peppered around where this Nevada test site is. So the people are back at work. A 1.6 near Alamo and so forth. So we've got 6 on the map here. These are all under 1 or under, so they're small. And now let's come on down this east side of California. Here's the Mammoth Lakes area. Look at these 3 all in a row, but it's more than 3. They're stacked. We just think it's 3. Wait, let's go back out. Okay, I've got that one too. So we've got 5 here, including that one. So we've got a 1.1, a 1.4, a 1.5, a 2.0 is the largest one, and a 1.8. So 1.8 and a 2.0 at the same place right here. So we got 2 right there, and they just came in within a minute of each other. This one happened at 5:23 this afternoon, and this one happened, the 1.8 happened at 5:24. So there we have it, in pairs. They're coming in pairs. Then moving on down, here's a little one, 0.1 up in the northern part of Death Valley. Here's a 1.7 near Coso Junction, and 1.2 near Cyril's Valley. 1.3 near Kernville. 1.8 near Lamont. Let's come back and get these coming down the San Andreas Fault. Here's a 1.5 near Alum Rock. Here we have a pair, a quarry blast, 2 quarry blasts near Aromas, California. One at, this one was a 1.6 magnitude that came in at 1:16 this afternoon at a minus 0.1 kilometers depth. And another, and then a 1.0 that came in at 1:17 this afternoon at a minus 0.1 kilometers depth. So I guess they didn't think one blast would do it, though they did 2. And here's a 1.9 near Tres Pinos. Here's 2. Here's a 1.6 near San Lucas. And a 2.1 near New Idria. All on that red line, San Andreas Fault line. Now let's move into Southern California, but before we go there, let's look at this one in Mexico, a 3.1 near Maniadero, Baja California, Mexico. This one happened at 2:07 this morning. Then in the Southern California area, try to get them all on the map here. We've got 35 here today. And they're all under 2.5 magnitude. So most of them are down here in this Kauai area, is what we're seeing. Here's Kauai, 28. So there's that. They're all kind of piling up here. The largest one, it looks like, was a 2.2. So I think that's a wrap. We went extra long today. I presented a lot of data, a lot of research, articles, news items. You know, I'm just trying to keep everyone informed of what's going on, and just to remind everyone that time is so short. We really are in the end times, and no one knows the day or the hour. And given that, especially, you know, that buoy was out, and that 6.2 and then the 5.0 earthquakes over here in the Atlantic Ocean, and that could have easily caused a tsunami that could have come across depending on the depth. But time is so short. I just really believe that we all need to get down on our knees and ask for forgiveness and get right with God and Jesus. Get your spiritual houses in order, and just do it. Just do it before it's too late, because when you've got a 200-foot tsunami wave coming down on you, you're not going to be thinking about getting right with God and Jesus. That's going to be too late. You're going to be a deer in headlights. So I think that's a wrap for today. I love all of you very much. And until next time, God bless you. Go in peace, and goodbye.